Hello children, welcome to channel Sube. Children, today I am going to discuss question number 38 from the MCQ part of 2022-23 Physics New Syllabus paper. Three identical conducting spheres A, B and C are mounted on insulating supports and separated as shown in the figure. The sphere capital A is given a charge plus 3q and C is given minus 2q charge. The sphere B does not have a net charge. This one is neutralized. Then the sphere B is first touched to sphere C. So this one to this one. Next sphere B is touched to sphere A again. After that this one to this one. Sphere A, and finally separate spheres brought back to the identical initial positions. The remaining final charge in each sphere is given by so there are final charges given in this table. So children, this question is not a difficult one, so let us try to solve this problem. So let us take a copy of this given diagram. So children, they are not closer as in the figure, so the question means that these spheres are separated like this at a considerable distance separation. So since these spheres have same radius, r same radius, they have the same capacitance, because C capacitance of a sphere is 4 pi epsilon naught times r. R is the radius. So since the radius is equal in each sphere, so this capacitance also equal. So therefore if we touch two spheres like this, so first what they say, this sphere, what they say first, the sphere A is given, the sphere B does not, then the sphere B is first touched to sphere C. So if we touch this sphere to C like this, what happens, since the capacitance are equal, this charge that is on C is distributed between these both the spheres. So some charges I delete therefore here, and I add them to this one as well. So like that. So equally the total charge is distributed among the between these two spheres now, since the capacitance are equal. So therefore this minus 2q, now what happens, distributed among these two. So what happens, this one gets minus 1q and this one has minus 1q remaining. Totally it had first minus 2q. So like that, now this sphere B has a charge minus q. So now what we do, this one we take to the sphere B and touch to that, so like this. Then what happens, this minus q will disappear, because plus 3q add to minus q. So what happens, these both, the sum is finally plus 2q neutralize. This minus q get neutralized by this positive 1q and remaining positive 2q in this capital no, not in this capital A, in the system. In the system, now finally we have only 2q in the system. That means for the both spheres, So this 2q plus 2q, what happens, equally distributes among between these two spheres A and B. So now B gets finally positive 1q and A has positive 1q. So that is what happens finally. So then final answer is this one. You understand, I think, because initially this sphere B had minus q. So from this plus 3q, 1q is used to neutralize this minus q. So remaining here now only now 2q. Now 2q. So these two neutralize each other and disappears. So like this. So now the system has only 2q. So that 2q distributes among these between these two spheres. So each gets 1 1. That means finally like this 1q positive. So finally this one is constant, it doesn't change after touching with this touching to this B. So it got this minus q previously, so it is remaining there, not change. So the answer is minus q here, minus q here, then this one B plus q, these are wrong. So capital A plus q, this one. So finally the answer is the fifth one. Fifth one is the answer. So let us check the answer sheet. Question number 38. For 38, the fifth one is the answer. So correct. So we have successfully solved the question now. So children, if there's time, we can discuss some target questions. Children, I made a target question for you. So now try this target question number 1, this one. So try to solve this on your own without looking at my answer. Now pause the video and try it. I have done little changes to the question, original question. You can try this. Now pause the video and start. Since you have started, I am going to try this question. Two identical conductors. So this radius of this each spheres are not equal as it was in early question, in previous question. So the radius of this one is r, and let us take a copy first of all. Suppose the radius of this one is r. So this one is r divided by 2. They say in the question the radius of conducting sphere B is half of that A and C. So this one is r. So now you can't solve as we did in previous question, because the capacitance is now difference. You know the equation for capacitance for a sphere 4 pi epsilon naught times radius. So C is proportional to the radius. Capacitance is proportional to the radius. So here the radius is half. So the capacitance is suppose this one C, this one also C, then this one has a capacitance equal to C divided by 2, half of C. So let us take the first incident. These two touch each other. So what happens when we take this one closer to this one and touch to this C like this? Since the capacitance is half, now the charge, the B, what the charge the B sphere get is not same as the charge that the sphere C gets. The total charge is minus 3q, so let us keep it aside. So now what happens, the charge distribute between these two until the potentials are equal. So voltage VV, potential, so voltage we can say V, and here also V. Until the voltages equal, what happens, the charges flow from this one to this one. So suppose at that moment this small one gets a charge capital Q1 and this one gets a capital Q2. So now we can find out the total, since the total charge is minus 3q, so we can write Q1 plus Q2 must be equal to 3q. We can neglect the minus sign. The magnitude is 3q. Totally we have 3q charge. So since the voltages are equal, now we can write V equals V. V equals V. So what is the equation? We know Q equals CV. Yeah? So V equals Q divided by C. So we can substitute it here. Q1 divided by, now we know this one has C divided by 2, the capacitance, if this one is C. If this one is C, this one is C divided by 2 because the radius is half. So now we can write here C divided by 2 for this smaller one and equals Q2 of this bigger one, Q2 divided by the capacitance is C. So this 2 goes to the numerator, 2 times Q1 divided by C equals Q2 divided by C. So C cancel. So we get what? Q2 equals 2 times Q1, 2 times Q1. So 1 to 2 ratio. So totally we have 3q. So this one gets therefore 1q and this one gets 2q because 1 to 2 ratio. The bigger one gets 2q. Q2 equals 2 times Q1. So Q2 is this one, is equal 2 times what the charge this smaller one has, that is capital Q1. So easily we can ratio, we can distribute the charge among these between these two spheres because they have given 3q, which is easily simplified. So otherwise we can substitute this equation if you want to really calculate how to do it. Q1 we write as it is, then plus Q2 is equal here 2 times Q1, then equals 3 simple Q, then 3q, 3 capital Q1 equals 3 simple Q, then cancel this 3, then Q1 equals 1q, 1 simple Q. So like that we can calculate. If you want this one to calculate, if you if you want to calculate it, you can calculate like this, and then the total one equals 3 simple Q. Therefore this one Q1 is simple Q plus capital Q2 equals 3 simple Q, then capital Q2 equals when we take this one to right side, so 3q minus q, then that means 2q, 2 simple q. So like that you can calculate if you need, but not necessary because they have given 3q, so that it gets easily simplified. So by heart, by mind, we can just divide without writing anything, as I did previously, like this, q and 2q here, because total charge is 3q, so the ratio is 1 to 2. So 1 to 2 means we have to divide into this 3q into 3 parts and give 2 parts to this one and 1 part to this one. So like that, however, we get finally q and 2q. So from here we can select, we don't have to calculate furthermore, we don't have to touch it with this A, because final charge of this C, final charge of C is 2q, 2q, that is minus, because previously it had minus from the beginning itself. So I neglected that, I said it when I was calculating. Minus sign we can now write. Here also minus sign should be there, because it had no relationship between this positive one. Still it is contacting with this only minus 1. So final answer is minus 2q. So minus 2q answers only 1 here. Therefore we can select this answer as the correct one, third one, minus 2q for sphere C. But if you are not satisfied, I am going to continue. I am not going to stop here, but at the real time examination you can stop here. You don't have to calculate the other one. So finally we get this one, this one and this one. So now let us touch it with this one. What happens when you touch it with this one? So carrying a simple q charge, so this one is coming. I take room here. C divided by 2 we need the charge. This one has what? Minus q, minus q. So it touches with this one now. Again I have a problem. This one we take to this side. C divided by 2. So touch with this capital A now. So what happened initially, at first, at the beginning, this minus q is cancelled with 1 plus q from this 4q, plus 4q add to minus q. What is the resultant? The sum, final one, plus 3q, because 1q is neutralized due to this minus q from this positive 4q. So the remaining charge is, the net charge is positive 3q. So this one now change like this, how this 4q becomes 3q, because 1q cancels due to neutralization with this minus q. So minus q disappear, minus q, and from here plus q disappears, and finally the remaining charge is 3q for both for this is in the system. Now we have only 3q for these both spheres. So now we know how charges are distributed. From this 3q, 2q stays here in this bigger one, only 1q goes to this smaller one. As previously, I don't calculate again, as we did here, the same way, because the radius here is same r, and r divided by 2 this one. So the same ratio, at the same ratio this charge distributes between these two spheres. So like this, 2q, the positive, and this one also positive, because the negative charge carried from this C is now disappeared. Because it was neutralized by this positive 1q from this 4q. So now the remaining final charge is positive 2q on the sphere A, and this one positive simple q on this B, 2q q, 2q q. So we have already selected this one, 2q q, all are positive, only C is negative. So children, now we have done this one, finished. The third one is the answer. We didn't have to go this way, this much. I told you that we could have stopped here after calculating this one. So children, I think you understood. This one is a little bit difficult than the first one, because you should know these things, and to get the ratio. So however, this is how you have to solve this question. Children, try this one, the target question number 2. I changed the question a little bit, not a little bit, considerably. I changed the question. So now you can try it without looking at my answer honestly. Stop the pause the video and start. Children, since you have stopped the pause the video, now I am going to try this question. So let us take a copy first. So as previously, this one touch to, this one is touch to this one, as in the question. The sphere is then the sphere B is first touch to the sphere C. So when B is touched to C, as previously, this one gets a simple q charge, this one gets a minus 2q charge. So I am not going to explain that again, as I explained it in the previous question. So since this one has r divided by 2, half times r radius, then this one. So that is as previous. So now what they say, this one is taken and touched with A from inside, like this, not from outside as previous, but now here from inside, like this. So there is a gap here, there is a hollow space, so that we can insert this. From inside we can touch this like this. So then what happens, this total charge goes to the outside surface, this q, the simple q goes to the outside surface and neutralize with this plus 4q, and the final charge outside is now 3 plus q. This q vanish because that is negative. So finally we have 3 plus q charge on the bigger sphere outside of the sphere, outside the surface. So as previous question, now this sphere B doesn't get any charge because it is inside of this bigger sphere. So this one doesn't get any charge because the charges don't go inwards like this. The charges don't go because there is a huge repulsion among these positive charges. So therefore they can't go inside, they can't be closer, they can't go closer to each other. Therefore the inside sphere now has no charge. That means the B has finally no charge. So finally B has no charge after taking out of this sphere. So finally it has no charge, 0. This 3q remains here. So the final answer is 3q 0 minus, this one is minus, it is minus, here you see. So minus 2q. So this one is the answer. So children, this principle we call Faraday's ice pile experiment. So using that principle, an instrument is constructed that we call Van de Graaff generator. I'll show you a picture. So this one you might have seen. This one is called Van de Graaff generator. So there is a gap like this, so that we can reach from inside. We can take any charge from along this gap and touch from inside. So the total charge goes to the sphere. Nothing remains on the charge, on the object that we brought. It has no charge. So this is the instrument. So you can check about this in the internet. So I am not going to explain here that. So that is called Van de Graaff generator. So that is the principle that is being used in that Van de Graaff generator. That means if we give any charges from inside, that goes to the outer surface totally without remaining in the object that we brought inside. Nothing is remaining in the object that we brought from inside. If we brought a sphere having a charge from inside and touched from inside, so the total charge goes to the outer surface. Nothing is remained here in this on this object that we brought in. So that is the principle. Totally the charge goes to the outer surface. So therefore finally this B has no charge, so therefore it is 0. So children, I think you can understand this thing. So I think now the time is we have used 20 minutes, more than 20 minutes sometimes. So therefore I am going to wind up this video. So children, I am going to wind up this video now. I think you are happy. If you are happy, what you have to do, you have to subscribe my channel if you haven't yet subscribed it, and also share my link among your friends so that I get a bigger audience, and also press the thumb up icon, and that means give me a like to this video so that this video is pushed automatically by the YouTube. Otherwise it will goes to a corner. So therefore please give me a like for this video. So children, then see you tomorrow at 6 o'clock in the evening. Goodbye. So long.